Hello guys, welcome to part 2. There could be a part 3 because this may take a while again. So what I'll do is I'll try and make chapters so you can sort of skip through in places. The next step is just to check that I have soldered this microcontroller to the board okay. What we need to do is just check the pins, and I use my microscope to do that. I'm just going to grab it and grab my PCB, and then we can get a really close look. Now, oh, I've got it wrong way. Yeah, there we go. There we go. And as usual, what I tend to do is I tend to view this in negative also. So what I'll do is I'll just minimize that again. Put that over on my left. Yeah, let's put that down there. Well, let's get menu up. Turn on negatives and open that window, and let's put that there. Yes, so I'll get rid of that. Right, so yeah, it just gives me sort of like two views at it and two attempts to pick up any issues. So they look okay. And let's work along. Like I say, you saw how much solder I put on there, and I tell you, you don't need much at all. These pins are tiny. Tiny. I mean, I don't know if I can show you how tiny they are. So anyways, just take a look at different angles, just to make sure. You don't want to be looking straight down on them. You want to see if the legs are lifted or anything like that. And if I can get the focus on this right. Like I said, there's no depth of focus on this microscope. But yeah, if you can just see it, all I'm doing is looking at the solder to make sure that there's like a fillet around the leg. Then you know you've got it. Let's try and look down at the end here. Try and get that in focus. Get a sort of like a perspective on it. Yeah, there we go. Like I say, you've got to sort of refocus as you look down. But that looks alright to me. So what I want to do, like I said before, this was a... I didn't take this out of the this chip in out of the box. It's one I had on another project, and I was having issues, and I didn't know if it was the chip or the driver that I was using, so I took the chip off. So what I've done is I've stuck it on here to see if it works. I mean, they're cheap enough, these. I think the cost of these chips are nothing. I think I got 10 for about £6 or something like that, you know. So it brings them down to sort of less than £1 each. Yeah. So right. Yeah. So what I'm going to do. Right. Let me just get rid of this and set something else up. Right, yeah, so when I make these PCBs, I've got this fly lead here, which, if you see there, yeah, so it's got this header on it, and then I've got these little bits of wire with pins going on, and what I can do is I can solder them to my pads on the back here, and that's what I'm going to do. But so before I continue, I just want to check this this microcontroller, because I'm not sure whether it'll take the program, so let's just check that anyways. Normally I would just take a brand new one and put it on there, and I wouldn't have to do this, but I'll show you everything. You can skip through whatever. Yeah, so normally it's all based on one of these modules, and these modules have these pins on the programming pins on the end there. Basically, there's 4 pins, and I based this. Where are we? So we've got our. Let's see. So we've got our positive. So our power's on the right here, and you can see the second one in is ground on the left, and that's what I based this header on, and my wires. So what I do is when I put my pads, let's get on there. So when I put my pads on here, I put them on in the same order that they are on these on these modules. I put them in the same order. So where are we? Yeah, so that's it there. So we've got VDD on the left, and then there's well, I say swim, and then with ESS, and then reset. So that way, my standard programmer, where is it? The cable I use that's attached to my standard programmer, it fits. You know, what I use for programming these modules will then plug straight into this header that I have really. Hang on, that like so, and having sold these little leads that solder onto my PCB, it means I can do, you know, because it's not a permanent attachment. I can just solder them on there temporary while I program it, and that way I can actually make some PCB smaller than I need, because I don't need the space. You know, those pads are right behind the microcontroller, and not putting any through holes or anything makes it easier locating them when designing the PCB. So that's what I'm going to do now. Is I'm just going to solder my fly leads onto my PCB. I don't know if you need to show that. No, I'm going to pause. Oh, I nearly forgot to mention what I want to show you. Can you see that I've put 4 blobs of the solder paste on these, rather than use my soldering wire with flux cord? I just want to show you what will happen, because what I did was I've oh, it's quite out of focus, that, isn't it there? Hang on. Not better. No, that'll have to do. Yeah, so here what I've done is I put 4 drops of this this solder paste that has a lot of iso alcohol in it, and there's one thing I just wanted to mention is, if you try to solder this with a soldering iron, what you're doing is you're putting instant heat on it. When I was doing the surface mount devices, I was bringing the heat up relatively slowly, if you get my meaning, and so the iso alcohol had time to evaporate out of the solder. But as it stands now, these blobs of paste, solder paste, have iso alcohol in them, and if you put heat on them instantly, basically it'll just explode. So I just wanted to show you that effect, so that if you're thinking of using the little syringe and a soldering iron straight on the mix of iso alcohol and paste, to show you what happens. It's not really bad. It just makes a bit of a mess, and you've got to clean it all up. So I'll just show you that, because what I'll do is I'll just melt this solder before I put the pins on. So yeah. Yeah, you can see it all sort of spurt all over the place, and that's basically the iso alcohol just boiling straight out, and as it boils out, it just makes a mess and spreads the flux. The solder all over the place. You can pick it all up with your soldering iron, but it just makes a bit of a mess when you have to clean it up really later. So I just wanted to show you that because it's a little technique that because of what I've done with the solder paste. Normally I'd just use my reel of flux cord solder to tin these pads, but hopefully you can see what happens when it's full of iso alcohol and you add a bit of heat. Right, so I'm just going to solder these on and I'll be right back. Yeah, right there, I just soldered them on. Right, so now what I can do is we can take this end I've got here and I can plug that into my programmer. So I'll just program it. My programmer's plugged into USB, so it's going to give power to it. So yeah, just plug that in. I like to paint markers on because make sure I get the right connection the right way around. There we go, you can see that. So yeah, so that is now plugged in. Right, we don't need our microscope for the time being. I'll just get that out of the way. And we just need the bench. So you can see that. I'll just see if I can get a bit of focus. Yeah, so I have my fly leads and I just solder them on and then I can unsolder them later on. But the thing is, using pads I can make the PCB smaller and I can locate these wherever the hell I want. Right, so that's plugged into the programmer. So what we need is the programmer. What I have is this, which is from ST Microelectronics. It's ST Visual Programmer. And I've created some files, so all we have to do is open the file. So we've got the 3 tabs. We've got the options bytes, and so we load that in, and we get the option bytes and load that in, and then we've got the memory bytes. Well, I've already done it here, you can see there, look. This is just for the EEPROM, and I just put some crap in there just to you can see if anybody sticks a programmer on it, they can read this. So we just get that file as well, and that's the memory, data memory. And then we also get the actual program. Now the actual program, so we load that up, and the program I will actually call it whatever, give it the name of whatever I'm currently making. So we'll load that in. So that's the programmer, and I use Visual. The programmer, rather there is a code editor and you can program using the code editor, but the reason I use the actual visual programmer, you can visually see how much memory you've used. So if I scroll down and then we just keep going till we get zeros, there we go. So you can see I can roughly see how much memory I've got left there basically to program it. But you can see that I've used up the majority. We finish here, and if you look at this space on the right hand side, you can see that I've practically filled it up. I have had some programs where I've actually gone down to the last byte here. Anyways, I'm rambling again, so I'll continue. So we load the 3 files in. Normally in my Instructables I tell you to do the program, and then I tell you to do the memory, and then the options bytes. I'm going to change that now. So what I'm going to say is we do the options bytes first, and the reason being is the microcontroller that you have could have protection turned on, and we need to turn off the protection. Also, with some projects I also need to change what the pins do. The pins can be swapped out. If we look at these AFR7 and 6543210, those 8 bits, they can be changed. That what are they? if you've done other types of microcontroller, it's a bit like the fuses. It's a bit like fuses, these. And what you can do is, if you've set a fuse correctly, you can actually tell the microcontroller which what the pins need to do. You've usually got a few choices. What it does, it just swaps some little connections around inside the microcontroller, so it turns things on and off in the hardware side of things. So this is important anyway. But it's the read out protection. We need to turn that off so we can program it with the other two tabs. So what we do is we just click on here, download, and we should see a red and a green bar at the bottom. Well, you didn't see the green bar, but it was there. Again, it says here they're successfully verified. That was the green bar, which is down here. This is 8 bits. Well, no, actually, it's 8 bytes. So you've got 1, 2, 3. I don't know if you can see here that there's actually 8 bytes that we're actually changing. So and then next, memory. You might see the green bar this time because the memory is a bit bigger than the 8 bytes. So we do the same again. We download that. There, I think you might have seen the green bar that time. So the red one is programming and the green one is verifying. And then we do the program memory. Right, you should see it this time. So we now program the program memory. So we click this button again, and there we go. And there's the green. Okay, so I know this microcontroller is okay. I've been able to program it, talk to it, so we're going to leave it on and see how it goes. The next thing I want to do is actually check that it is actually running. So I'm going to need, it's pointless putting the other stuff on in case I need to stick it back on the hot plate. If I need to stick it on the hot plate, I need this area to be flat, and if I put my through hole stuff on, I'm going to have pins sticking out here, and so I'm not going to be able to lay the thing on the pad. So next thing is to talk about the OLED. Hold on, I think someone's at the door. Right, yeah. So I need to check this out. Now, this is different to the one I had before. I've got my fingerprints all over the screen. A bit of ISO, I'll clean that off later. Right, so, yeah. Oh, God, I'm making it worse. Right, forget that then for a minute. Yes, so... This is different to the one I had before. The holes are different, and the pins are different. So, like I said before, I've done. All right, yeah, this is clever, isn't it? Right. So, yeah, I've put all those wires on, and they're all covering up my pads on the thing. Yeah. Right. So, yeah, have a laugh. Let me get in focus so you can see what I'm on about. There. I need to get to these pads to solder them. So give me a minute, I'm going to spin these around. Actually, I've just... oh God, I've got something in my throat now. I've just left them off. I've programmed it, so it should be okay. Yeah, I just had to have a big cough there. Right, yeah, so if I just get my bloody light out of the way. Yeah, so I've just left them off, and what we can do, what I need now is, I need to solder these 4 pads. It just needs to be on one side, the side that we choose. Can I get that any closer? Yeah, maybe that's better. Yeah, so you can see that it's like a triple pad, and you either choose one side or you choose the other. And so what we need to do is to find out what pins we want in here. So what I do is, let's just go back down to this level. Right, and then so what I'm going to do with this LED is I'm actually just going. I'm not going to put a female header on here. I'm just going to solder these pins all the way through like that. Let's see if I can get that in shot. I'm just going to solder it on right down like that, basically, so the pins go all the way through, and it's only just, hang on, where I get it so we can see sideways. There we go. So it's going to be sit like that, basically. I've got it on piss. Hang on, get it right. There we go. So I'm going to have it sat like that when I put it on. I'm not going to solder it right now. I just want to test it before, because you never know, I might need to get back to the microcontroller underneath. But what I'm doing is I want to know which pins are which. So the best way to do this is stick it how it goes, which is like this. So it's going to sit like that. But can you see? Can you? Oh, let's get that. Right. Can you see that? Let's get. Oh, where's my hand? Give me a minute. Yeah. Right. There. So you can see that all these pins are marked up. We've got VCC there, and we've got ground, and we've got SCR. Is that clock or? Damn, I can't see. Whatever. Might be better once I've turned it around. And we've got clock and data. Yeah, that's data, the end one, and the clock one there. So we need to remember that. But remember, we're going to, when we turn the thing round, it's flipped in the opposite direction. So you got to. So what I'm going to do is, yeah. So what I recommend is you stick it in how it goes. So I've got this back to right. Stick it in how it goes, and then you sort of lift it out. And well, see if I can do this right. Let me do it down here, sort of thing. Yeah, that's better. Right. So you imagine it like that. So what you do is you take it out and you flip it like that, going like that way, and then stick it back in on this side like that. If I can find the holes, let's get some hair around them and it'll go better. Right, so yeah, and so it goes back in. So what I've done is I've basically I've just flipped it round like that and gone back in. So then when I lay it down like that, we have the pins in the right order. Because I haven't turned it, I've just flipped it over and back, so that I can see the what pins we have. I'm going to have to make a thing so my camera can be dropped down lower, but it ain't. I've just got it on a thing, so I'll lift that up and so you can see. Yeah, maybe that's better. There. So now we can see which pins VCC, which is ground, and which is clock SCL, and which is data SDA. Is that right what it says? I don't know. And then we need to solder the pads. So I'm just going to do that. Okay. Let's see if you can see that. Let's get it a bit closer. There we go. So we'll get my hand. So pin one is down here, which is I've selected power, so I've bridged it here. And pin 2 is VSS ground, so I've done pin 2 here, soldered that bridge. Pin 3 is the SCL, the clock, so I've bridged pin 3 here. And pin 4 is SDA, so I've bridged pin 4 here. So I hope that makes good sense. Right, be right back. Right, yeah, okay. So another laugh. I realised that I need some power to power it up, so I'm going to power it from my programmer. So I've actually put my programming leads back on, and I've put them in that direction this way, so we can still get to them. Not that we need to anymore, but you know, this is the way I should have wired it up in the first place. So what I just need to do is just check now, totally check that the microcontroller is programmed okay and it actually runs and works. So I'm just going to temporarily stick the OLED in the socket, well, the holes in the plug, and I'm just going to sort of lift it up slightly and just wedge it with my thumb there. So what I've done is I've just made it so let's see if I can get them. So these pins are making contact. The pins are making contact in the hole. Really, I just want to make sure that those pins are making a contact. So I'm just holding it up gently against the holes so the pins all touch. And let's just put some power on and see if it actually works. So power's on. Oh right, yep, there we go. Yeah, there. So it is actually working. Is the microcontroller. I did not need to throw it in the bin. So there we go. Right, so we can continue. Now we've done that test. Give me a moment. Using these 2-pin headers like this, I'm using sort of male headers. You may want to, depending on your servos and what you're using for power, you may want to put a female header on the inside, on the side that we power in, because you may have this header on your leads that actually power your servos. So you can just break your servos apart, put put the plug in here and put the socket on here. Me, I because I'm not using remote controlled cars and stuff like that, where I'm using the servo leads. I do robots, so I end up making my own power leads anyway, and so I am putting male pins on both these. Okay, right. Okay, right, I just want to mention, right, I just use a bit of glue tack, you know, the glue tack for sticking stuff to the wall and what have you. Yeah, I just have a little blob of it, and that's what I use when to hold some stuff in place. So if we take one of the headers and we put that in through there, like that, that's how it's going to sit. To hold it in place, I'll just stick a bit of glue tack on top of it like that, and then just line it up like that. Have we got that? Line it up, a bit of glue tack is holding it, and then I'll solder one of them legs. Okay, get that in focus. Oh, yeah, there we go. So let's just put a bit of solder on there. What I'll do is I'll pick the one that isn't ground, and then we can just check it afterwards. Hang on, which one is the ground? Right, that one I think. No, that is ground, that one, so that one isn't. Still in shot, hopefully. Bit of solder on here, on this end one. Oh, turn my soldering iron on. Silly me. Right, don't know if that's in shot. Yeah, like I say, 300. Yeah, this right. Yeah, I used to have it lasted me years, but my other solder, I tell you, it's all down to the solder, I think, because I need to put a bit more heat on this solder. It's shit. Right, so I've just soldered that one. Just take that off there, take away my bit of glue tack. It does melt it. It makes it soft, but it does come off once it's cool. grab that. A bit got stuck underneath the pin. There we go. So it comes off. Okay. It's getting a bit old, is this? I've had this for years. Right, so I just check that it's all lined up. See if I can do it on camera. Yeah, so just check that it's all nice and lined up and happy with it, and then we can solder the other two. So let's have it that way around. It's still in shot? Yeah. Hang on. My little warning to say my tea's at the right temperature is just pinging away. Right. Soldering iron. And the other two. Yeah, I tend to keep using this boost a bit more. Mind you, the pins are quite heavy and thick, so I probably need to put a fair bit of heat into these actual pins. This is the ground one, so I'll put a bit of boost on for that, but once it starts running, just let go. And it's fine. So we'll do the other one on the other side. Stick that in there like that. Make sure it's sat flat. Put me a bit of... Like I say, it's getting a bit old, is that glue tack. But that looks okay to me. So I'll just solder one of the pins. Like that. And just check, get rid of my glue tack. There we go, that's come off better than last time. So we just check that is all lined up. And we got a bit of glue on there. Ah, shit, made it worse. There we go. Yeah, just I'll see if I can get it on camera. Yeah, just make sure it's all nice and straight. Get it in the light. Ah, shit. There we go. Oh, there we go. My hand's in way. Right. Yep. So that looks okay. So I'll do the other two pins. There we go. That was nice and easy. So now we just need to put on the what is it? The LCD, isn't it? Oh, not the LCD, the OLED. Yeah. So it's the OLED next, which is here. Stick that in there. As I say, I'm just going to put them pins straight through and then solder them in place. So just using me a bit of glue tack, I'll just stick that under one corner there like that, and right, I'm just going to take it out of camera shot. I just want to make sure this line is lined up perfectly, so give me a minute. Yeah, that's it. I just want to get a really close look with my eyes. I'm blind as a bat. Also want a bit of light on. Right, so I just want to get that perfectly lined up that way. Get it perfectly lined up this way. Right, I think what I'll do is I'll just do one pin, like usual. We're still in focus. Sort of, I think. Let's just check. Yeah, I think it is. It's close enough. You can get the gist of what I'm doing. Solder. One pin. Let's get number 1. Put a bit of boost on. Got a nice big pin there to solder. Yeah, so that's that one. I think this solder might be alright. I think you've just got to get used to what you've had. I mean, I was using lead-free stuff for years. Oh, it's just lifted a little bit as that. Don't know if you can see there, it's just lifted, so what I'm just going to just put my finger on and just hold it down while I add some heat to that pin. Let's just put a bit of boost on that as well. Let's get it down at this end. There we go. There, it's sat flat now, and yeah, it looks level that way as well, and it looks lined up that way. I think I could do with edging this way a bit there, just to see if it will. Bit of slack in the holes. Let's put a bit of heat on that. As far as it'll go over. Just doesn't seem to quite line up with my you know, things need to be lined up right for me. I've got one of those eyes that can see when something's not straight, level or vertical, so it really irritates me when something isn't. So are we in shot again? Oh, that looks alright, so I'll just do the other 3 pins, and I'll do the first one again because it got a bit ugly. Hang on. Camera and lights in way. I hope that's all in focus. Do the one at this end. Yeah, it's not the best solder I bought, so it'll do. I'm getting tangled up in wires now, microphone wire. Right, so yeah, that's that done. Right, so I'll get rid of my bit of oh, I never washed it in the bloody sink either. I forgot to do that. I know. I don't think it'll matter with this. I'll just have to be gentle with the screen, but I can still put it in the sink and wash it with a bit of fairy. Yeah. So yeah, that's the next step. Well, I'll tell you what. Let's just stick 5 volts in and see if it still works. So I've got my power lead here. Oh, what did I do with the servo? Give me a minute. I'll just find my servo as well. Right, so I've got my bench supply. It's got 5 volts to amp set. Let's just plug that into the power. The power is, the middle one's 5 volt. Oh, the other thing as well, what I tend to do, let me just do that, because I end up plugging things in the wrong place. So what I do is I send my wife off to get some nail varnish. Comes in these nice little bottles. I've made this rack for it. and so yeah, nice little bottles of nail varnish. Send the wife for it, and so she can tell the wife it's for her husband. Anyways, so what I'm going to do is I'm just going to put some marks on. Oh, I don't need it on this side, do I? Oh, I'll put one there. That's in the wrong place. I'll wipe the other one off. Totally frigging cocking this up. Right, try again. I'll put the pin. There we go. Right, that's the red bit. And a bit of yellow. Yeah, like I say, it just helps me a bit of. Oh, let me just get rid of that. A bit of colour, just it's a lot easier to see than actually read some numbers and stuff that I've written on the thing. Colour stands out a lot easier. It takes no effort to see colour than it does to read something. So yeah, what I've done is let's get it a bit closer. There, you can see that. Where's my hand? Yeah, so you can see I've done that middle pin red there, and I've done that pin red there, and I've done that pin yellow. And if we look on the other side, you can see that I've painted that yellow and that red, and it tells me that's the data signal. I've got it written here, but I find seeing colour better than actually seeing the plus 5 volts. If I haven't got my right glasses on, it looks blurry, but red still looks red and yellow still looks yellow. So that's why I do that anyways. So yeah, I've done that. And so what we can do now, where's the focus? Yeah, it's about focused there, isn't it? So yeah, so the power, so and see, I've marked my leads power. I've got a red lead here, but when I'm holding it, I have the red on the. So there's the power. Power goes on there. Oh, it's not very good connection there. Sorry about that, guys. Don't know why I'm coughing. I take a lot of codeine. Right, so and there's me servo, and so we've got the yellow wire. We know the yellow wire wants to go to the yellow, so we'll plug that on there. So there's my servo. Let's see, let's put it down. Just check the focus. Yeah, that's not too bad. What I'll do is I'll probably do another video of how to actually use it, but I'm just going to turn the power on and see what happens. Let's see if it goes bang. Oh, we see smoke. Here we go. Nope, it seems to be working just as expected. And I've done no cock-ups on this. Well, I don't think I've done any cock-ups on the board this time. But there we go, and let's not get the reflection. So is that in fuck? My lead's too short. Right, so yeah, so that looks alright, and my servo, let's see if it actually works. So let's turn it to, well, let's try the buttons first. So that should be one way, yep, and this button should be the other way, yep, and this should be back to centre. Wow, it actually works, it actually works. Hip hip hooray. And like I say, what I'll do is I'll set this up so I've got my screen on my magnifying, well, actually, let's do that. Let's do that now. Right, sit it back down there. Yeah, we don't need another video. I think. Well, how long is this one? Oh, we're at 49 minutes. So, right, let's say 10 more minutes to just show the thing working. Give me a moment. Alright, yeah, there, I would go like that. The colour's shit again, so, right, so, where's my hand? Right, so you can see that we've got this little indicator here. That tells us what mode we're in, so we're in pulse width mode, which is 1500 microseconds, which is 1.5 milliseconds, and so that's this center of a servo, and we've got a period of let me just try, I'm just trying to move that. We've got a period of 20,000 microseconds. So the 20,000 microseconds is from this point to this point. The 15 microseconds is from this point to this point. I should have said the period is actually from this point to this point. So that's the period, and this is the pulse width. So our duty is about, well, I don't know, about 5%, is it? Anyways, and this is roughly what the legacy servo position should be at 1.5 microseconds. If I push one of these buttons, or these preset buttons down here, this will take it to the max and min. I've got my finger on that button, haven't I? There we go. I was just trying to think. Oh, just move that forward. Let's move it all forward a bit out of shot there. Right. Damn. Oh, I've messed it all up. I really totally freaked that up. Where am I? Oh dear. Right, hang on. Get it there. Right. Okay, I'm just trying to line it up nice and square. I just hate things not being lined up and square. Right, yeah, so I should have... where's my hand gone? Where's my sodding hand? I've lost it. I cannot see it for just hang about. Yeah, I couldn't see it for looking at. I'd moved it right down out the way down here. Right, yeah. So you can't see that button now. Anyway, we've got one button there. So middle one way and other. So I'm just going to press these buttons. So you can see that the period. You can see the period change here. Sorry, you can see that the width changes here, but the period stays the same here, right? Okay, and we should be at plus 90, but this is a microcontroller from China, and it's about 45. It actually needs more than 2,000 microseconds to turn it any further. You probably need another half a millisecond, another 500 microseconds. Which we can do because we can do it manually. What I'm saying is that these buttons are the legacy right, left and middle. So what I'll do is I'll go the other way, and you should see that the the pulse width should alter. There. So you can see the pulse width altering as I turn the servo, put it back to middle, then one way, then the other way. But the period stays the same. So to alter the period, we can move this by just pressing the button, the actual encoder button. So you just push this down, and this will change this down to here and put us into period mode. I'll just do that. There we go. So now we're in period, and we should now be with the encoder. We should now be able to change the frequency. I've done some presets all the way up to 300, and what you'll see is that the period, so from this point to this point, will get shorter. And I've just put my hand right over the hertz, so there we go, 100, so it's going twice as fast. Then we go 150, it's going 3 times. And you can see that you've got like an oscilloscope readout, and that's, it can go as fast as 300 hertz. Now that's the fastest it can go with the enhanced pulse widths, but you can go faster. And the reason they go faster, these servos, is for these new, I don't know if you've seen them, these new remote control or intelligent, what is it, intelligent maze solvers that go around a maze, but you need them to go around really, really fast, and they need to be able to turn the wheels and stuff really, really fast, and that's why these servos now go, you can get servos that actually go up to 500 hertz. And it's so that they can do all this navigation and turning really fast. 50 hertz is too slow for them to go really fast, so that's the reason for this extra frequencies. But you want to be able to test your modern servos, and that's why I've actually built this servo tester, so that you can get the high frequencies. This only goes up to 300 because I've allowed for the extra pulse width modulation. The faster servos will go from 1 millisecond, which is 1000 microseconds. If I push the other button, which takes it to 2, right, so that's the big one. It only goes up to 2. Well, sorry, the fast ones that go higher than 300 only go up to 200 microseconds, because you've only got this much space left. Can you see the distance between the pulse width? You've only got like another microsecond left, another millisecond left of space to put one in. But the reason I've capped it at 300, it's not hard to change through the firmware, but I've capped it at 300 because these modern little servos, actually you need to increase the pulse width down to 500 microseconds all the way up to 2500 microseconds to get them to turn further. So I can show that by actually turning put it back into pulse width mode. So I press the button and we're now in pulse width. So now when I turn the encoder, it will now adjust the pulse width, and you will see that this pulse width gets really, really bigger, and the servo will now turn to 180 degrees. And you can see like at this extra pulse width here, I'm enabling here to actually take it all the way to 2.6. There we go, that's the max my thing will do. But the legacy servo should have turned 198 degrees, but in fact this one has actually just gone over 180, well 90 degrees sort of thing. So you sort of have to put twice as much pulse width in here. I'm sure those that mess around with servers and find this useful will understand what I'm trying to say. Yeah, but you've got nothing left here to go any faster if you increase the hertz. So yeah, I hope that well, I hope people understand why I've actually made this, because it's a lot better than what you've one of these. Hang about, here we go. One of these things. All this can do is go to the legacy at 50 hertz. So it won't. One of these things will not turn. Hang on, I'll put that there. One of these things will not turn this 180 degrees. You need something better than this to actually turn that 180 degrees, and that's why I've actually also made this. So if we put the period back to 50 hertz, just press the button, and then we can just turn it down to 50 hertz. There we go. And then we just go back to period, and we can still adjust the pulse width and turn the server all the way back around to another complete 90 degrees. So there we go. So you can see that actually the pulse width of my tester will go down to 440 microseconds, which is like is 0.4. Actually, it goes longer than that. It goes to 4. There we go. So that's 0.4 milliseconds. So you've got a really tiny pulse width here. Hang on, let's get that back in shot again. There we go. Yes. So and like I said, I'll just press the button to put it back in center. And there we are. So it all works great, and I've got no repairs to make to this. So I'm really quite pleased with this. I hope those that have watched it to the end found something interesting, and like I say, it's a handy tool to have if you mess around with the modern microservers. I'll catch you later, guys. Thanks for watching.